Okay, so in this video I'm going to talk about sets, and I'm going to talk about the basics or the fundamentals of sets. So I'm going to talk about what a set is, the different types of sets, how you represent sets, the symbols we use when we talk about sets, or the notation, and things like that. Okay, so let's look at what a set is first. Well, a set is just simply a set of well-defined objects, or a collection of well-defined objects, if you like. So for example, we can talk about we'll call this particular set A, okay? And I'm going to talk about the set of, let's say, farm animals. So if we look at a set of farm animals here, usually what we do is we enclose our set in these kind of curly brackets here. So this is our set of farm animals. Now let's have a look at another one. Let's say we talk about set B, and let's say set B is the set of or the even numbers, from 1 to 10. Okay, so now we're going to say this set B, we're calling it B, and this is the set of even numbers from 1 to 10. Well, let's just list those. Well, they would just simply be, so B is, let's see, the set of even numbers from 1 to 10 would start at 2, 4, 6, 8, and 10. Okay, so we've represented the set B here in English, if you like, and what the set B exactly is in numbers. So both of these are ways of representing this particular set, and this method here is called the rule method. It's the rule method. So you state what the set is in English, if you like. And this set here, or this method of representing this particular set, is called the list method. So two ways of representing sets here. Okay, so let's look at the different types of notation that we would normally use when we talk about a set. So let's take this set B here. We have these numbers 2, 4, 6, 8, 10. So we're going to talk about a few of the words that we use. So let's take the number 4 here is called an element. I'll just use a different color here. So let's use white. So this number 4 here is called an element. An element of the set B. Okay, so any of these numbers here would be called an element of the set. And if we look at our set of animals up here, if you look here, you've got geese. So one of the geese here would be an element of the set of farm animals, and so on. Okay, so the way we would represent that is, let's take the number 4 here. So we'll take the number 4, and we would write this symbol here, which means the element of. 4 is an element of the set B. So instead of actually writing down 4 is an element of the set B, so instead of writing this down, which is quite a long sentence, we just abbreviate it to 4, this symbol here, this element of, and B. So it makes it a lot simpler to write out. So 4 is an element of the set B. Okay, so that's our first symbol, this little e. Now, we have these numbers 2, 4, 6, 8, 10 in the set B. So let's take, for example, the number 9. 9 is not an element of this set here. So the way we write that, we'd write this E here again, and we just simply put a line through it, and the B here. So this is just simply 9 is not an element of the set B. Okay, so again, instead of writing all of this out here, which again is a long sentence, writing that out every time is going to take quite a while, so we just simply write it like this. 9 is not an element of the set B. So we write the symbol with this E here with a line down through it. Okay, so that's element of. Now the next thing I'm going to have a look at is what's called the cardinal number. Okay, so the cardinal number. The cardinal number of a set. So the cardinal number then of a set is just simply the number of elements in a set. So for example, in this particular case here, we have 1, 2, 3, 4, 5 elements in the set B. So we would write the symbol for cardinal number is just this hash here, and we would write down B after it. So this means the cardinal number of B, and we found that there are 1, 2, 3, 4, 5 elements in B. So the cardinal number of B is 5. There are 5 elements in B. So that's another symbol then. So we have element of, not an element of, and cardinal number. Now let's just talk about one other set then that we come across quite a bit, and it's called the empty set. The empty set, or sometimes it's called the null set. The null set. So the empty set is just simply, we can draw these curly brackets again with nothing inside. That's called the null set. Or we can represent it by a circle with a line down through it. So either of these will do. These represent the null set, a set with nothing in it. Now I'm going to talk about the next part here. We're just going to talk about subsets. Okay, subsets. So let's take our set again. Let's take the set B again, and B was the set. This set here, 2, 4, 6, 8, 10. So this is our set B. Now let's talk about subsets of B. Well, a subset of B is just a set that contains some or all of these elements. So some or all of these elements. So let's talk about, let's say, the set C, and let's say just take 2 and 4. Well, 2 and 4, the elements 2 and 4 are part of this set here. So the set C is a subset of B. Or if we take another one, let's take D for example, and let's take, I don't know, 6, 8, and 2. So D is the set 6, 8, and 2. Well, we can see that 6, 8, and 2, 6, this one, and 2 here are in B. So we can say D is a subset of B. And the way we write that is D subset of B. In English, we would write it just simply as D is a subset of B. But again, there's a lot of English here, so this is very short and sweet here. So we just write D, this symbol C here, which stands for subset of B. Now, if we take another set, for example, let's take E this time, and we take, let's say, 1, 2, and 4. So set E contains the elements 1, 2, and 4. Now the elements 1, 2, and 4 are not in this set here. 2 and 4 are, but 1 isn't. So the entire set E, this is the entire set E, is not a subset of B. So the way we write that is just simply the same again, you probably guessed. It's just E, or symbol C with a line through it, and B here. E is not a subset of B. Okay, so that's what a subset is. Now you just got to remember as well that there are two types of subsets. So let's just have a look at those two. The first one is called a proper subset, and the second one is called an improper subset. Proper and improper subset. Now, a proper subset is just any subset of, let's say, B here, any subset of B here that contains 1, 2, 3, 4, or 5 even, because we're going to talk about the null set as well in a minute, that contains some of the elements but not all of the elements of this set. It might be easier actually to just describe what an improper subset. An improper subset is a set that contains all of these elements here. Okay, so for example, if we have, let's say, the set, we'll say the set F, and the set F contains, let's say, 10, 8, 6, 4, and 2. Now this set F here contains 10, 8, 6, 8, 10, 8, 6, 4, and 2, which is all of these elements. So the set F contains all of the elements of B. So this is a subset of B. F is a subset, so we can write F is a subset of B, but it's classed as an improper subset because it contains all the elements of B. Any other set is called, a subset rather, is called a proper subset. So if we have the set G, and that is, let's say, contains the element 2, this is a proper subset. It just contains some of these elements, but not all of them. A set that contains all of these elements is called an improper subset. Now, one thing I should mention as well is we spoke about the null set a minute ago. The null set is a subset of all sets. So there is a subset of set B here that is the null set. Now, the null set is classed as a proper subset. So the only improper subset of the set B is this set here, a set that contains all of these elements. Okay, so let's have a look at another set. How do you know how many subsets there are in a set? I'm going to have a look at that now. So for example, if we go back and call this, we'll go with A again, and we'll just call the elements 1, 2, and 3. Okay, so we have 3 elements in the set, in this other set A. It's a different set A than the set we used up here. So we'll just call this set here A. Now, if we were to list the subsets of set A, let's say we would start with 1. There's a subset of A. It's a proper subset of A. We've got the set with the element 2 in it. We've got a set with the element 3 in it. These are all subsets of the set A. We've got another one with 1, 2 in it. We've got another one with, let's say, 1, 3 in it. We've got another one with 2, 3 in it. So these are all subsets. These are subsets with 1 element, subsets with 2 elements. And we also have the set itself. The set itself is a subset of A, is a subset of this as well. This is the only improper subset. And then we also have the null set itself. The null set is a subset of all sets. So how many did we get? 1, 2, 3, 4, 5, 6, 7, 8. We ended up with 8 subsets. 8 subsets. Now, that's okay. You can list the subsets of any set and just count them. That's fine. But the problem is, if you have a set with a lot of elements in it, you're going to end up listing them. It's going to take you a while to list them all, and you may make a mistake. You may leave out some. So how do we work out this the number of subsets? Is there an easy way to do it? Well, there is. If you take 2, raise 2 to the power of the number of elements in the set, in this case 3. There are 3 elements in the set A, so we raise 2 to the power of 3. That will give us 8. 2 times 2, so we just do 2 times 2 times 2, which gives 8. So there are 8 subsets. So for example, if we have another set, let's call it again, let's say B, and this has 2, 3, 4, 7, 9. Okay, now this has 1, 2, 3, 4, 5 elements in this set. So how many subsets does this have? Well, we can list them all, but we might make a mistake. We may miss 1 or 2 of them. So the number of subsets in the set B is 2 to the power of 1, 2, 3, 4, 5. 2 to the power of 5. So that's 2 times 2 times 2 times 2 times 2. 2 multiplied by itself 5 times, so that's 2 2s are 4, 2 4s are 8, 2 8 16s, 2 16s 32. So there are 32 subsets for the set B. So you can imagine trying to list all those. You'll surely miss 1 or 2 of them. So this is an easy way to calculate the number of subsets of any particular set. Okay, so that's it for that little bit. Let's just have another look at another element of sets. So we're going to have a look this time at Venn diagrams, what are called Venn diagrams. So Venn diagrams are just another way of representing sets. So if we take, for example, the set A again, and let's say A this time contains 1, 2, 3, 4, and 5. The elements 1, 2, 3, 4, and 5. Now we can, this is the list method for representing the set A. We've just simply listed all the numbers. So there is another way of representing the set A, and we just simply draw a circle. We draw a circle like this. We put A on the outside to show us that this represents the set A, and we put the elements inside that circle. So we got 1, 2, 3, 4, 5. And we put a little dot next to them just to show where the particular element is. So this is our set A. Now, if you've got two sets, if we let's say have another set, we'll call this other set B. And let's say B is, let's say 4, 5, 6, 9, 12. So this is our set B. We can represent B using a Venn diagram as well. Okay, so we draw a circle and we put these numbers into it. Now let's just have a look at what's called intersection and union. So we're going to have a look at two new words. One is called intersection, and the other one is called union. Okay, so what do these two words mean in terms of sets? Well, let's take the sets A and B. Okay, we're going to take the sets A and B, and we're going to represent the two of them using Venn diagram. So I'm going to draw two circles. So this is my set A, this is my set B. So this is set A, this is set B, and I'm going to let them intersect here or overlap. I'll do another two here because I'm going to talk about union in a minute. So we'll do the two sets again over here. This is set A, this is set B. Now let's have a look at A here. A has the elements 1, 2, 3, 4, and 5. B has the elements 4, 5, 6, 9, and 12. Now the numbers 4 and 5 are in both sets. So what you can do is put 4 and 5 in the middle here. You can see that 4 and 5 is in both circles. It's in both sets. And then put the remaining ones outside the center here. So if we look at set A has 1, 2, 3, 4, 5. So we can put 1, 2, 3 here. 4, 5 is already in this circle, so that's fine. B has 4, 5, 6, 9, and 12. So we're going to put 6, 9, and 12 here. Okay, so this part here is called the intersection of the two. This part here, we could shade that in if you like, just to show you exactly what I'm talking about. So we're talking about this part here. That's called the intersection. And intersection is usually, if I represent that using our notation, we would say A intersection B equals 4 and 5 here. The numbers 4, the elements 4 and 5. And we use this symbol here, an upside down U. So A intersection B is represented by this symbol here, this upside down U. So A intersection B is are the elements 4 and 5, this part here in the middle. And the way we would say that in English is the elements 4 or 5 are common, if you like, to A and B. We talk about the elements that are in the elements in A and B. This word and is very important. The word and here represents this part here, the intersection, the elements that are in A and B. So let's just do that again over here. So let's look at this. We got 1, 2, and 3 here. 4 and 5 are common to both sets, and then we have 6, 9, and 12 out here. Now we spoke about intersection here, so it's where the two sets or the two circles overlap or intersect. So they contain that contains the elements 4 and 5. Now what about union then? Union is it's the elements that are in A or B. So the way we write that is A. Now I'll do that in different color. So this would be the elements that are in A union B. A union B, so we use a U for union here. And they would be the elements that are in both sets. So in other words, we're talking about 1, 2, 3, 4, 5, 6, 9, and 12. So it's all the elements in both sets. Now 4 and 5 are in both sets. We only write them down once. Don't write them down twice. So these are the elements in A or B. And again, here it's very important that you remember this word here, or. It's they're the elements in A or B. So it might be a little bit misleading, but this is the word that we actually use when we talk about union. So the elements that are in A or B would really be represented by everything here. If I was to shade in the region, I'd be talking about all of this here and all of this part here. So it's everything in both sets. So intersection is just this bit here, and union is everything in both sets and the intersection as well. Remember these two words, and we associate with intersection, or we associate with the word union. And that's it for the moment on